Welcome to what might be the most important lecture in this module. We're going to look at real-world AI implementations. And I'll be honest with you, we're going to focus primarily on what went wrong. Now you might wonder, why lead with failures? Shouldn't we be inspired by success stories? Here's my reasoning, and I want to be transparent about it. First, verified success stories are remarkably hard to find. When you dig into the impressive claims companies make about their AI implementation, you often discover the evidence comes from the companies themselves, their press release, their earning calls, their marketing materials. Independent verification is rare, and as leaders making investment decisions, we need sources you can trust. Second, and more importantly, you don't learn to avoid the cliff by studying people who walk safely down the middle of the path. You learn by understanding where the edge is. The patterns that lead to failure are consistent, well-documented, and, critically, avoidable. If you understand these patterns, you can design your own implementation to sidestep them. So in this lecture, we'll examine 4 real cases, 3 clear failures, and 1 that started as a success story before running into trouble. Each is documented by independent sources, news organizations, court records, academic audits. I'll give you full references so you can verify everything yourself. Let's start with the sobering statistics, then move to the stories behind them. According to research from the RAND Corporation published in 2024, AI projects have a notably high failure rate. Some estimates suggest 80% or more. The RAND study, which interviewed 65 experienced data scientists and engineers, identified consistent patterns in why these projects fail. Gartner adds another perspective. They predicted at least 30% of generative AI projects will be abandoned after proof of concept. The reasons? Poor data quality, inadequate risk controls, escalating costs, and unclear business value. And here's perhaps the most striking finding. A July 2025 report from MIT's NANDA initiative, based on analysis of over 300 AI deployments and interviews with 150 executives, found that 95% of generative AI pilots delivered no measurable impact on the profit and loss statement. 95%. These aren't numbers designed to discourage you. They're numbers that should make you determined to be in the 5% that succeeds. And that starts with understanding why the 95% failed. Our first case is Amazon's AI recruiting tool, reported by Reuters in October 2018. Starting in 2014, Amazon developed an AI system to rate job candidates on a 1 to 5 star scale, much like how customers rate products on their platform. The goal was automation. Feed in 100 resumes, get back the top 5 candidates. By 2015, they discovered a problem. The system had taught itself that male candidates were preferable. It penalized resumes that included the word women's, as in women's chess club captain. It downgraded graduates from 2 all-women's colleges. It even favored certain verbs like executed, captured, that appeared more frequently on male engineers' resumes. Why did this happen? The AI was trained on 10 years of resumes the company had received. Because tech is a male-dominated industry, the majority of those resumes came from men. The AI learned from historical patterns that reflected existing bias. Amazon edited the program to make them neutral to these specific terms. But they couldn't be confident the system wouldn't find other discriminatory patterns. They scrapped the project in 2017. The lesson here is fundamental. AI learns from the data you give it. If your historical data contains bias, your AI will learn that bias and potentially amplify it at scale. Our second cautionary tale illustrates a different kind of risk: legal liability for AI mistakes. Jake Moffat's grandmother passed away in November 2022. He visited Air Canada's website to book a flight and asked the airline's chatbot about bereavement fares, a kind of lower-priced ticket or last-minute travel due to the death or imminent death of a family member. The chatbot told him he could book now and apply for reduced bereavement rate retroactively within 90 days. Based on this advice, Moffat booked full fare tickets costing over $1,600. When he later applied for the bereavement discount, Air Canada refused. Their actual policy didn't allow retroactive applications. The chatbot was wrong. What happened next is remarkable. Air Canada argued in the tribunal that the chatbot was, quote, a separate legal entity responsible for its own actions. They claimed they couldn't be held liable for what their chatbot said. The tribunal member, Christopher Rivers, called this a remarkable submission. He ruled that chatbot is part of Air Canada's website, and the airline is responsible for all information on its website, whether it comes from a static page or chatbot. Air Canada was ordered to pay damages. The lesson: you cannot outsource accountability to AI. When you deploy an AI system that interacts with customers, count on owning its outputs, including its mistakes. Our third case is one of the most expensive AI failures in healthcare, IBM Watson for Oncology at MD Anderson Cancer Center. In 2013, MD Anderson partnered with IBM to develop an oncology expert advisor, an AI tool that would analyze patient records and medical literature to recommend cancer treatments. The vision was compelling: democratize the expertise of top oncologists to patients everywhere. MD Anderson spent $62 million on the project before canceling it in 2016. A University of Texas audit identified delays, cost overruns, and procurement problems. But the deeper issues were technical. Watson had phenomenal natural language processing skills for structural data. But medical records are messy. Data might be missing, written ambiguously, or out of chronological order. Doctors use abbreviations. Notes are inconsistent about instructions. Notes are inconsistent across institutions. As Dr. Amy Abernathy, then at Duke Cancer Institute, put it, the MD Anderson experience is telling us that solving data quality problems in unstructured data is a much bigger challenge for artificial intelligence than was first anticipated. Internal documents also revealed that Watson's training was heavily influenced by practices at Memorial Sloan Kettering, meaning its recommendations often didn't align with local guidelines or real-world cases elsewhere. IBM ultimately sold Watson-held assets in 2022. The lesson: the complexity of real-world data is often far greater than anticipated. Don't underestimate the data preparation work, and be cautious about how well solutions trained in one context transfer to another. Our fourth case is perhaps the most instructive because it's not a simple failure. It's a story of initial success that ran into trouble. Klarna is a Swedish fintech company. You may know them for buy now, pay later services. In February 2024, they made headlines with impressive claims. Their AI customer service assistant, built in partnership with OpenAI, was handling 2.3 million conversations per month. That's the equivalent workload of 700 full-time human agents. The CEO projected $40 million in profit improvements. The investment community was impressed. The tech press covered it widely. Here, finally, was a clear AI success story. But then something interesting happened. By May 2025, Klarna announced they were hiring human customer service agents again. CEO Sebastian Siemiatkowski was remarkably candid about what went wrong. His words: "We focused too much on efficiency and costs. The result was a lower quality and thus not sustainable." Let me repeat that. The CEO of a company that had become a poster child for AI-driven efficiency publicly admitted they had overcorrected. Customer satisfaction had dropped. The AI-only model wasn't delivering the quality the customers expected. Now, Klarna is moving to what they call an Uber-style model, flexible human agents working alongside AI, rather than AI replacing humans entirely. This case is valuable precisely because it's not a simple failure. The AI worked, the metrics were real, the cost savings were genuine. But optimizing for one variable, efficiency, came at the cost of another variable, quality. And Klarna had to course correct. The lesson here is that AI success isn't a destination, it's an ongoing calibration. What works in 1 month may not work in month 12. You need feedback loops. You need to watch for degradation. And you need the humility to change course when the data tells you to. The Rand Corporation study I mentioned identified 5 root causes of AI project failure based on interviews with 65 experienced data scientists and engineers. Number 1, misunderstanding the problem. Business leaders often miscommunicate or misunderstand what problems need to be solved using AI. Number 2, insufficient data. Organizations lack the necessary data to adequately train an effective AI model. Number 3, technology obsession. Organizations focus more on using the latest technology than on solving real problems. Number 4, infrastructure gaps. Underinvestments in data governance and model deployment systems. Number 5, unrealistic expectations. Leaders don't understand AI's actual capabilities and limitations. Ongoing monitoring. They treat deployment as the beginning, not the end, with feedback loops to catch quality degradation early. As Klarna's experience shows, what works in month 1 may not work in month 12. McKinsey's 2025 research supports this, while 78% of organizations now use AI in at least one business function. More than 80% say they're not seeing tangible impact on enterprise-level profitability from generative AI. The gap between adoption and value capture is real. I want to leave you with a realistic but empowering message. The statistics we discussed, the 80% failure rate, the 95% of pilots with no P&L impact, those numbers are real. But they describe a population that includes companies rushing into AI without proper preparation, without clear problems to solve, without data readiness, and without realistic expectations. You now understand the patterns that lead to failure. You've seen them in real cases with real consequences. $62 million at MD Anderson, legal liability at Air Canada, public course correction at Klarna. This knowledge is your advantage. When you approach AI implementation, you can ask, have we clearly defined the problem? Do we have the data we need? Are we solving a real business need or chasing technology? Do we understand the complexity? And do we have mechanisms to monitor quality after deployment? If you can answer those questions honestly, you're already ahead of most organizations attempting AI implementation. The goal isn't to avoid AI, it's to implement it with the clear-eyed realism that separates the 5% from the 95%.